We're continuing our look at different types of atoms, and now we're looking at something called isotopes. And isotopes are different forms of the same element. Different forms of an element. And the way that they're different is they have different numbers of neutrons. So they have more or less neutrons than each other. So let's look at actually what isotopes are when we look at their atomic structure. And here we've got one of the most common elements on Earth, and particularly one of the most important ones for living things. We've got carbon. So here's what carbon looks like. And carbon, we've discovered, has 3 different isotopes. And you can think of isotopes just like different species or different breeds of a dog or a cat. They're still a dog, but they look a little bit different. And it's the same with isotopes. So all these carbon isotopes, they still look like graphite. They're black, and charcoal is made of carbon, and they're powdery as well. So all the isotopes have the same properties, but in their atoms, they're a little bit different because of the number of neutrons. So we can see here, the first carbon isotope, it has 6 protons, of course, because the element carbon always has 6 protons, and it has 6 neutrons. The next isotope of carbon still has 6 protons, but it has 7 neutrons now. And then the last one has 8 neutrons. So remembering that subatomic particles have a mass, they actually weigh something, and protons and neutrons, they have a mass of 1. So the first carbon isotope, if we weigh, and if we say the mass number of the first one here, mass number is the number of protons plus the number of neutrons. So for the first one, we've got mass number of 12. The next one, 7 plus 6 is 13. And then in the last isotope, it's a mass number of 14. And that's how we actually name different isotopes. We call the first one carbon-12, and this is the most common carbon isotope. And then the next one's called carbon-13, and the last one is called carbon-14, surprisingly enough. And actually, carbon-14 is radioactive, and we'll learn a bit more about radioactive elements later. So with isotopes, one of the next most important things to remember is that a sample of that element, it will have a mixture of all the isotopes together. So carbon-12, 13 and 14 are all mixed together inside one chunk of carbon. We can't separate out individual atoms because they're too small, and they all just mix together naturally. The next thing to think about with isotopes is that in nature, they don't all exist in perfectly equal amounts. We don't have, well, with carbon, and this happens for most elements actually, there's normally one isotope that is really, really common. And most of the atoms in a sample are made of that isotope. And that's true for carbon-12 here. So we can see carbon 12, whenever there's carbon in nature somewhere, making up our bodies, there's lots and lots of carbon inside humans. 90, we can see 98, nearly 99% is all carbon 12. And there's only about 1% carbon 13 and a lot less than 1% carbon 14. So which means if we have a chunk of carbon and it might be the carbon in our lead pencil, because that's what we use to write with now, since there's no longer lead in pencils. We've got our chunk of carbon. That means nearly all those atoms are carbon 12. There are a few carbon 13s and barely any carbon 14s. And on the periodic table, you might have noticed there's a second number down the bottom that seems like the mass number, but it's not exact. It's always in a decimal form. And this is called the relative atomic mass. And this tells us information about what's the average mass of a carbon atom when we have a natural sample of it in real life. So to calculate that number, what they do is we take the mass numbers of all the different isotopes. So we've got mass 12, mass 13 and mass 14, and they take an average of that, but we take into account it's an average mass of the natural isotopes. But they take into account how common they all are. So remember, carbon 12, really, really common. Carbon 13, there's not much. And carbon 14, hardly any. Not very mathematical, but that's how many there are. So it's an average mass, and it's called a weighted average. Or in other words, it's including how common each isotope is. And another name for that is abundance. Abundant means common, so the abundance is how much of that isotope. So we can see for carbon, its relative atomic mass is pretty close to 12, because most carbon atoms weigh 12, but a few carbon 13s and a few carbon 14s mean the average carbon atom is a little bit more than 12.